So you're given about 0 index to the integer array grid, size of n, height, and which represent field. 3 values: 0 represent grass, 1 represent fire, 2 is where that you and the fire cannot pass first. Okay, grass and fire. Now you want to traverse to the safety house here. Every minute you can move to adjacent grass field. After you move, every fire will spare. Oh, okay. Oh my god. So 1 minute will say we spread this 3 minutes. Okay. So if this is impossible, you can always reach a safety array state return maximum numbers of minutes that you can stay in the initial position before moving until the safety reaching the house. Okay. So okay. Interesting problem. We cannot want to use 1 minute because selecting 1, so we never reach this. And what is the grid? It's 30. So yeah, I know the constraint is 300, right? 300, and the n per dot is smaller than 2. Think about this. So suppose that 3 minutes we can do that. So 1 minute we can do that. So okay, I have some ideas that we can binary search the minute we can stay, because if 3 minutes can do that, it means that 2 and 1 and 0 minutes always can do that. Yeah. So we have the answers. Suppose we have binary search, and now let's think. We have maximum number answers. Now let's just try to binary search the minute we can stay. So okay, so say that if this is valid, it means we can search more minutes, stay more minutes to the initial position. Otherwise, we don't have this. And yeah. Now what is value? Okay, value we say we just sprayed fire adjacent for adjacent, right? So we can use BFS to do that. And after we BFS to do that, say this. Let's just try each minute we will keep to spreading the fire. Okay. Keep spreading fire. but you need to sync the fire. We have some directions here, and now we consider that we must do this. It's going to be 9 minutes, right? We must be 9 minutes here, and just try to if the distance to the shortest path of this is more than this minute, that means that okay, we always can reach the path, always can reach this, always can be reachable, and we know that if this is reachable, it means we can traverse to the top right. Okay, so now we have valid time step. And so we have a 10 is going to agree, and let's try to for still need to calculate the shortest path. Size. And no shortest path distance. We must be smaller, because if equal, we cannot do that, so we must be smaller the distance, and we still have fire distance. Okay, now let's just try to do just use BFS approach, and okay, just BFS. Okay, what is the time complexity? Here's going to be the okay, just keep push the fire. Each time. Going to be index minus J is going to be index more than, and now we need to push the fire initial state is okay, is the grade J is going to be fires 1. push that the fire distance is going to be 0. Initial state is, okay, this is BFS, and zero here. Okay, we push that and add on G. Yeah. Okay. And this one. Push the fire and just try to traverse the fire. Okay, we don't need to do that. Don't need to use the 10 because we never use this. Okay, and we just try to do 4 directions here. Okay, is compare of I minus 1 J, I plus 1 J and minus 1 J, and I J plus 1 I J minus 1 is smaller than 0, or J is smaller than 0, and I is greater than n, and J is greater than n. Or okay. 3 is glass. Okay, we set 10. We use 10 because we will change that. It's a fire. Not 0. Say this is an J here, and we just say okay, let's just fire array. If this is fire array, and you will push back. And I heard that add ball G. Okay, now okay, we know the fire distance will still be 0. Yeah. Okay. Now let's just traverse. After we traverse, and then we just try to calculate the shortest path. Calculate the shortest path. Okay. Now say if AJ is going to be 1, push this shortest path here. so we don't use this. We don't need this because we can simplify this initial state and traverse this. Okay, now let's just try to do that. We calculate the fire distance so far here and just try to traverse until the time state. You know, this will be use this again. Traverse this. Okay. Now we have what? We also have start positions. Q. Okay. Now we just calculate the distance. Okay. Okay. Let's say we don't really color this, and we just forgot to parp. That will make this TOE. Okay, I +1 minus 1 and 1 minus 1 and okay. Say the distance. The fire stem is going to be 0, and we will add the fire stem. Okay. Fire distance. Square time. Fire distance. Okay, we don't need this. We just use that we update. More, and if this is greater, we just do that. Yeah, and now after we traverse through this path here, and well, so long. I just use the shortest path distance again. We color the temp. Okay, and this is calculate shortest path to do that, and we still need the last shortest path to target. Okay. Okay. And should do distance to 0. We will say Q will push 0. Now let's just try to calculate the shortest path from start point. distance smaller than distance at 1. Just use this. Okay. Actually, this two is the same, so we can merge them. Okay, but I'll just say now I just push 0 again, and we just say okay. So if this I is going to be -1 and j is going to be and -1 and -1, we will say okay, we can reach this, so we can return true. And for direction, and what should we do? Smaller than 0, bigger, and if the distance is greater than the fire distance, means we will never reach this, right? Yeah, push out this. Okay. First we traverse. Okay, we don't have this. Oh my god. 30 minutes is. Why? Suppose we have 0. And it's greater than -1. We have a tie. Size Q size pop and push. Distance is greater, we never reach this. So where is TOE? Oh, so means that okay, think about this. So if the first state we just push the fire and we traverse the fire, which is time state -1, we will say okay, grid is have fire, so we don't use this because this is not a glass, right? So we just try continue because we are already visit, and now I should find that. Okay, so we just find okay, temp is going to be I, just have this fire distance is going to be 0, and say calculate shall dispatch from fire, and we say okay, so if this is greater, we don't from this position to this position is greater, means that they are already smaller, so we don't use this. Okay, wait. And just interesting. 0, 0, 0. Oh, we don't have any fire. Okay, set. I want to see that. Okay. Calculate the shortest path here. Oh wow, there's a big bug. Okay. Wait. Calculate shortest path from class fire. This means where's time step? I need to consider what time step counts TLE here. Suppose this cube size. Push back this. Continue means, oh, wait a moment. If the temp is going to be fire or yeah, we cannot go into this because if the temp, we will not. Why? Okay, I want to use the visit array. Just okay. Look carefully. Stock on this. Now we know the J. A really simple idea is that we just use this. Okay, so this we may close the TLE here. Let's see why we will close TLE. 0. Oh wait. Okay, wait. Okay, we will say the 10. 21 because we never use this again. Okay, oh my god, it's -1. Okay, so what is this -1? So we have 0, 0, 0, 0. Can we reach this? Yeah, we can reach this. But basically, yeah, we never reach this. Oh wait, this is 0, exactly 0. Wait. So let's see the time. If we don't use this, we'll see the time. Okay, so this case. Actually, we can use 0. So if 0, we say the distance is okay. So we have. Oh wait. Okay. Wait. Wait. So we never reach this. Okay. And then now, what do? We say okay. Time is going to 1. Fire distance. Let's calculate the fire distance. Wait, let's see. This is sample. It's going to be. Oh my god, waste too much time. Let's go here and okay, let's see this. Zero two 0 1 0 0 0 0 2 2. Okay, so we will plus 0 0 0 2 0 0. Consider this example. 0 0 2 2 0 0 0. Okay, so now let's say yeah, in this case we say that what is the distance here? If the distance is more than 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 2 3 4 5 6 7 8. Oh, okay. So suppose that if we know the 1 minute here, say distance to this be 2. This is sense side here. So if we say the distance this, we just say, oh wait, in this case we need to consider that fires should be smaller. Else if this is equal, or say this is equal, and -1, it should be 0. Yes, yeah. Waste too much time. Okay, got an idea. so the buggy solution is that this case. The last position we can get earlier. Okay. Wow. Okay. Average distance. Now we have zero index numbers of Nelson. Average difference index I is the first one. So average difference of the index I is the absolute difference between the average of the first I plus 1 and the average last round down to nearest. Okay, so idea is brute force. We can just use linear approach, but basically we cannot use the linear time complexity. We can just use the perfect sum to do that. But the idea is that first and last, we just calculate the perfect sum. Calculate the perfect sum. Okay. And of course, that we need to calculate the minimum average difference. What this means, average difference? Average difference means the first I plus 1 element. For example, let's say this problem. Say is numbers. The first element index 0 is going to be average of 2, and the last. Okay. Round down to 0. So it's 2 minus 3. Okay, so we can just average difference. So first that the I plus 1 prefix I minus about the prefix minus I. It's the idea, right? Because there's 3 elements here. Okay. For the last element, subtract that the element, we don't need this, so it's minus 1. It's this element. Okay, don't use this. Okay, and we want to find the mean of this. Okay, now we just try to use perfect sum. Average distance I plus 1 and minus I minus 1, I minus 1 elements. So just say perfect sum. Okay, perfect sum. We use some plus 1 element to make more simple. This one is going to be I add all array numbers I, and want to record the index tree. So we just find the index. Mean of index. Okay. Numeric limit. If index selected 1, 0. Actually we can use this. Okay, so distance array is not empty, so we can use calculate the current. distance. This prefix minus I plus 1, 2 element so far, and minus about the prefix. Set prefix I plus 1, prefix minus subject that prefix minus I. That's 1. Okay. If wait, the sum may be greater than. So we need to make sure that the value is long. Need to care for this. And distance is prefix 1 or 1. We don't use this. And n minus 1, 0. And n minus 0 will say just use prefix minus 1. Wait, 0. Wait, why am I doing here? Just say plus 1. Yeah, say 0 would say we just minus 1. Okay. Actually, should we do set distance here? If current is more than the distance, it means that index is going to be I. Okay. Very simple problem. Runtime error, division by 0. Oh wait, okay. Wait, care for this. Okay. Okay. Some edge case is that because this will produce the division by 0, so we need to care for this. Yeah. Wait. Okay. So this will be numbers of elements, something like wait a moment. Think about this. Okay, suppose we have last and maximum 1, so we have 5 elements here. So we have n6 minus 0 is minus 1. And for this, we will say, yeah, so this, wait. If this is last element, zero. Oh, okay. So we should do that to more carefully. First element here, and right is going to be this. Okay. So if n minus I minus 1 is going to be 0, say 0, otherwise this, yeah, make sure that never happened. Yes, 4, it's 1, wait, it's going to be 0. It's going to be 0. Well, too many boxes problem. Yeah. Average 0 and consider be 0. Okay. Suppose we have prefix here, and we know that. Okay. I want wait. Think about this. So we have prefix element here. Wait. I'm just back here. This index about 1 is going to be 3 minus 5. 1, 2, 3. It's going to be 4. It's going to be 0. So current will be. Oh wait, we forgot to update the distance. God, just stupid. Okay. Just stupid. Okay. Took too much time. Okay, so the problem one, say a string words where words I and s comprise only lowercase number string words. A prefix means that there's prefix. Comprise lowercase means only have lowercase here. So if okay. So idea is just brew force for third word. We say if we have substring here. Substring is going to be 0. Sub2 is going to be the wait, we just try to use should we just use this? That's nice. If sub is going to be t, count at 1. Yeah, that's idea. Yeah, that's idea. Okay. Now this problem. It's give you 2 integers represent their index. You are also given to the integers raise guards the word. So we have the guards, the words position size guard and J's word respectively. Okay. How to do this? A guard can see 4 cardinal directions starting from their position as object by a word, not a guard. So we have the grid here, say the grid, and we also have the guard as this, and we have 3 guard, and want to see. Oh, okay, I know the idea. So That's not guard. It means that you can see, okay, this is be adjacent. Oh, okay, I got idea. So we can use a grid to do that. Okay, so guard is the calculate the number of grid that is not seen by guard. Okay, yeah. Now I'll just say is we just say that. Okay, so we can use additional array to do that. So we have grid here. So idea is that use array to record that and just say we just calculate further actions here, or we just use traversal to do that. For each guard, just try to traverse the 4 directions. Until I reach the word. Okay, say so we have grid. So we have a grid as initialized 0. Just calculate the numbers of the guard. We just calculate if the column is going to be 0. Yeah, and use the actual array, and we just try to simulate it. Okay. Let's say words. Okay. Say read. ij is going to be 1, means it's guard, followed by guard. 2 means this is words. Okay, we have word. Grid 0, 1 is going to be 2. And now I just try to do that for direction. So we say J is going to be 1. And we'll just try to do for direction. So while I is more okay. And grid ij is going to be 0. It's going to be this. Do the same things here. Okay. But we will have some cases that okay, we may not cover it because yeah, okay, actually this idea may be faux. Simulate is okay, this may be wrong. Actually we should do that. It's like consider that for each index we just see okay, if the forward direction will never have the G, never have the G. This means yeah. Okay, so we need to see the four directions here. Okay, so now how to do that? Yeah. This is well. We just say okay. So for this example, means this is 2. Okay, this is word covered by the word. Let's see. Wait. Okay, I want to simplify this problem because current approach is wrong. Because we just try to cover words to 2. Now we just try to see if there's further action have the words closest values the word. Okay, it's a word. So for example, say this, the left is going to be W and the right is going to be okay. So say how to calculate the closest approach, closest G here. Okay, say we said this, suppose we said this. Okay, guard. Suppose we set this, and we say okay, for each just try to update the forward direction. Wow, just another fucking problem because we need to traverse the forward direction to make sure that every element is not covered by the guard. Yeah, so let's say okay, let's see, so this we see this four directions, the first element, we just need to check that okay, so this is good, this is well because let's just say wait, okay, actually it's not hard because we just say okay, if we set the guard here, actually what should we do here? We need to know that okay, so if current is the word, say okay, this is left is good, that left is good. Okay, so I want to use the forward direction to do that. I want to use forward directions. Say for direction, but I want to make sure that there's for direction. Say if this is, that would say, okay, so left is good, left is good, left is good, left is good. Okay. So now let's say that. For directions, let's say that dp is for vector of oh my god. Okay. Now I just see, okay, if see the left for each direction, say let's see, okay, so left, see from left, you know, say dp 0 and ij is going to be good. It's good. Okay. Well, good is 1. Okay, if the grid ij is going to be 1, say good is 0. Else if grid ij is going to be war, that means good is 1. Good is 2. Okay. Wait, this is good. After this will be good. Okay, now we have, say, the positions here. We say that, okay, so this is bad, right? Because this is bad. You know, this is bad. Say, okay, this is bad. Okay, say, next position is going to be worse. Okay, this is good. Okay, just reverse this. Now we have the right positions here. Okay, so yeah. Now I'll just try to duplicate function this. See from the top. Swap this. Okay, I'll say this is 2. Oh, wait, we don't want. Okay. 3. Oh my god. So add all the zero, 1, 2, 3. Okay, this 3, 2, 1. For direction is good. It means that the DP is good. Okay. Just still be error. Okay. Okay. Let's finish this contest. Wait. Oh my god. What is this? We have 3 and 4. Okay. Suppose that we have a grid here, and actually what I want to do is okay. Say that the DP is just stupid error. Just a stupid error. Oh my god. Okay, finish this contest. Wow, took so long. Oh my god, just do very bad. Okay. Okay. Wow, awesome, man. 22 minutes. Oh my god, this problem took too much time. Yeah. Okay. Okay. Actually, finish time is too long. Okay. Now let's see that problem. So yeah, this problem is pretty simple. You just try to find out that the prefix of the s in the words. So for example 1, you just see, okay, so s is ABC, so how many words that is prefix? So A is a prefix, B is a prefix. Actually, you just use string compare, we just easily can calculate that. Oh, numbers of the prefix. Okay, yeah, so we just try to split the substring here, and we just compare that. Okay, the string is going to be equal, and we don't care about the t length is greater than s length, because this will avoid the problem. So we can easily just use substring. Okay. Yeah. And, okay. This problem, actually, you need to careful that the node tree element is considered empty element of array. The average should be 0. And this problem is that you need to find out that the index. You need to find out the index, and you need to calculate the average, the difference between the first element and the last element. For example, say example 1, just for each element, we just calculate. Okay, so this element and this 5 element, this average minus the last element average, and calculate the absolute difference. So we just say, okay, 3 to 2 0 1 4. We find out that what is the minimum of the average absolute difference between its index. Okay, now the idea. What is the idea? Because the constraint is power 10 power of 5, so you can use brute force approach. But you can easily use perfect sum, and you're careful that you can use long, because the sublist element may over the int max, so you need to care for this. And you also need to care for that if the right element we say, okay, it's all element, and right we don't have 0 elements, so we need to care for this. And you just care for also you need to care for that how to calculate prefix, because we shift by 1, we just add 1 and ascend the last element just equal, because you just think about the simple cases that, okay, you just subtract zeros and actually you just subtract 1. Yeah, that's the idea. And you can update the minimum distance and update the index. Yeah, this is still easy problem. And say this problem. Yeah, this problem think it's not easy. But I think there's more simple way, but I can figure out it. I just use very stupid approach to solve this. Yeah. And yeah. Now what is the problem is you need to find out that the numbers on guard cell. What does means on guard cell? On guard cell is that they don't have the guards cover it, and the guard will have 4 directions until the word. So I use a very stupid approach, which is, okay, we set the initial grid, okay, 2 and 1, and after that we just do 4 times. So see for our left, we have DP have the 4 direction. We can see, okay, so DP 4 directions is all the 1. That means all the good. So DP means that okay, this is the direction and this is the index. Means this is on guard or not. Yeah, on guard or not. So yeah, so the initial we just say, okay, 1 is guard and 2 is word. We set this. After that we just, okay, calculate the DP. Actually it's not DP, it's just the HR array, and we just see, okay, from the left, let's say if we meet a G, it means, oh, the good is going to be false, so the DP that left direction left and the current index is going to be bad. And if we meet the word, that means, okay, the next position can be good. So next position can be good. Okay, let's just do that. Okay, and similarly, the right direction is the same, and we just do top and bottom, top down. Yeah, this idea. Okay, and this problem. Yeah, this interesting problem actually. But Screencast a graph problem in the binary search, and so this problem is that you're given about 0 index array, and you need to find out that, okay, what is the sept house? What you can stay in your initial position, means that, okay, we can stay 3 minutes. So you need to find out that the maximum numbers of minutes that you can stay in your initial position. Okay, so yeah, so if you can always reach the safety house, so for example the word is around the fire, that means, yeah, you always, the maximum numbers of minutes is infinity, so we can always reach it, and we will return power of 9 or 10 power of 9. Yeah, so how to do that? Actually, you can observe that the number of the minutes is increasing. It means that 1 to 3, if 3 is valid, means that 2 and 1 also be valid. So we don't need to do this 2 minutes. And Yeah, so we binary search the maximum numbers of minutes for each state. Wow, let's see the dirty code here. So we first let's see that. Okay, so given the time, how to check this is valid. So we have the distance is and the fire distance. The distance means that okay, the shortest path from the start position to the end position, to the each grid position. So this is start point to or grid shortest path actually, and this is a fire to or grid shortest path. Yeah, and I just set a grid, and this valid kind complexity will be the OM. Yeah. So total overall is going to be log x. This is overall. Log x overall. Yeah. And okay, so now let's just say push the fire. Let's just traverse the fire to set the minutes here. Yeah, set the minutes here. And this maximum is going to be mn here. And we just okay, set true. After that, okay, let's just calculate the distance from a fire. Shortest path distance from a fire. Okay. So we set the initial state to 0, and from 0, okay, let's just try to traverse. Okay, we say that, okay, if this is already visited, we don't do that. And with this distance smaller, okay, we can start to extend our fire. After that, we just calculate from our start point. If this is already visited and the distance is just send. Actually, it's a send. This two functions the send. We can use additional function to simplify this too. Actually, yeah. And now let's just say okay. The last step is how do we determine that? Give you the fire. We can determine that okay. We have a path to the last index here. Okay, we're just starting from okay, push 0 and traverse 4 direction to see okay if this is not over the bound and the temp the grid is not fire or the word. Let's continue. And you just care for this edge case is that the last position can be overlapped. Yeah, because for example means you can see if there is a fire here, actually you cannot reach this position because the fires will spread to this cell. But in this home, that means you can spread. Yeah, because fires, if a fire is this and you are in this position, and the next minute you will enter the home and the fire will spread, but this is valid. And yeah, I just can't figure out that. Yeah, so there's edge case is like this. Okay, last position. Otherwise, okay, we just can push it. And we just set visit. Already visited. Use temp. Otherwise, we will have a cycle here. So you need to care for this problem. Yeah, this and this. Okay, care for this, and the problems just like this. Okay, so yeah, that's the 4 problems.